Okay, so now that we have seen the basics, let's actually have a look at the proceduralism a little bit more in detail, uh, a little bit more in depth. Okay. So yeah, what we'll be trying to create in here is basically want to show you the help of a sketch. I want to create a table which can be procedurally altered. Okay, so if I want to see, let's say, have a table created in this fashion. Okay, yeah. Have these legs, and of course, I they can be altered in the sense if I want to add more legs to this later. Okay, maybe right now there are four. I want to add five, six, seven. So okay, I want to change the diameter of this uh, the table. Okay, then what? Okay, maybe I want to have this maybe in a conical fashion, whatever. Okay, so I want this to be procedurally altered with respect to what let's say user wants. Okay, I want the height to be changed. Let's say. Yeah. So the thing is that I don't want it to be recreated. So if there is some art direction going on where probably there requires some changes to be done later stages. I don't want the object to be destroyed and a new one created right from the scratch. Okay, what will be the that will be the case which will be happening probably in Maya. So if there is any changes need to be done to the legs, probably I will need to add more legs. It will the initial model will need to be destroyed and I will need to create a new one. So the point here is what? How do I create the same thing in Houdini so that it can be procedurally altered interactively? That is, I need not, for example, add objects here. So I want to add one more leg. I will be manually creating one more leg. That is not the stuff. I want that this will be very interactive. Yes. And the point is that eventually it will be should be a digital object, right? It should be uh, an object which one should be able to like use. It can be used by anybody. All right. So how do I work with this? Just say, how do I work with this? Now you guys already know that we have a circle, right? And the circle do have a point. Right? Circle do have a point. So here what I will do is create a nice recipe for this. So I will give it a thought of how I will be creating it. Okay. So I need to think, I need to give a thought of what all the different elements which I'll be using to create a sort of asset like a table. Okay. So one thing what I will start off with is a circle, and I will also start off with a line. Okay. Now this circle will be the top of the table which I'll be creating. That will represent that. Okay, which will be a circle, of course. So this will be circle. Forgive me for my handwriting here, guys. And this will be line, right? Which I'll be using. Okay, so these are the two elements which I'll be using. The line will be the leg. Okay, so this will be the legs of the table. Okay, so eventually I'll be using a node which is called as copy to point. Copy to point. And I'll copy this leg to these points. So in fact, they will get copied here, they will get copied here, they will get copied over here, here, and all these points will have a copy of the leg. Okay, all these points. All these points will have a copy of the leg onto all these points, right? Now, just like in previous example where we saw that we were changing the columns. So in this case, if I change the segments for the circle, that is right now there is 1, 2, 3, 4, 5, 6, 7 segments, right? So I want that when I change the segment, the overall leg numbers are going to change. So if there is segment, let's say there are 5 segments, then there will be 4 legs. If there are 6 segments, then there will be 5 legs and so on and so forth. Alright, so in that way, the concept is working. Alright. Now the rest of it, of course, the height of this, of course, if I want to do so, if I want to adjust the height, I just need to adjust the length of my legs. And while doing so, they should be exactly at the base so that when I change the length of the leg, they actually change their length from the base of each of it. So it's only the tabletop which is going to go up. Okay. All right. So yeah, further, of course, we will be taking a look at how I can change the depth of the leg, whether they should be square, whether they should have a square cross section, whether they should have a circular cross section, whatever, or whether they should be conical like this or whatever shape I want them to be created from. Of course, the thickness can be adjusted. Okay, I want to extrude the thickness outwards if at any point I need that. So everything needs to be procedural. If there is any type of art direction needs to be done to this particular asset later. Okay. And I need not go back and redo everything. Okay, so let's take a look at this practically. Start by creating a circle. Okay. Right. Cabinet. Change the orientation to that. Select. Alright. I won't be transforming anything outside because normally what happens in other applications is you normally move everything. Okay. So whatever I'll be doing here in Houdini is something which will be relative to its original direction. Okay, or everything will fall within where it is. If I want to change anything, I will do so with the help of node. Okay, I want to change directions, I want to adjust the height, everything with the help of the nodes. Okay, nothing in the viewport. But I need to keep its original transforms as it is. Okay, so I will require a circle, which will be the tabletop. As I told you, I will also be requiring a line. All right, so I do also have a line in there. I have a circle, I have a line. Okay, I told you I will be using a copy to point node using copy to points node, where I'll be copying each of these points to the circle, right? So the points are now being copied to the circle, but I don't see the circle. Okay, so for that I'll be using a node which is called as a merge node. So that I could see both of them. Sorry. Yeah. First the circle to right bar. Okay, so we have copied all our lines of the circle. So if you take a look now, if I change the divisions, okay, the points which are individually copied onto these points on the circle will remain the same, right? The next thing is I will need to have these lines fixed onto the base, okay, in the sense I want the lines to be like this or the legs to be like this, right? So the legs will be like this straight and I will have the table on the top of it. Right now they are all falling at the grid, okay. So in this case what I will be doing is using rotating these lines so that they will be straight. All right, so I'll be using transform to rotate the line. Let's see, 90, that minus 90 on the top side. Okay, so if I change the length, you will see the length will change from that point on. Right. Now I want that the tabletop should remain on the top here rather than on the base. All right. So this is where a new concept comes into play, which is called as channel referencing. Okay, wherein which I will reference the length of this, okay, to the transforms of this onto the transforms of the tabletop, so that when I actually change the length of the legs or the length of the line, this will exactly stay in alignment with the length of the tabletop, will stay exactly in alignment with the length of the legs. What I mean is the distance of the tabletop from the ground is equal to the distance of the length of the leg. That is what should happen. Okay. Now, how will I know the distance? How will I change the different distance of the tabletop? This is my tabletop. All right. Circle is my tabletop. So I'll use transform. All right. Place it just below the circle, and if I use translate, it's going to move up. All right. Now, one thing what I'll have to do is match the length of the line, that is this, okay, which is 1 right now. So I will just need to match this length of the line with the translate here. So if this is 1, you're still exactly in the same place, right? Okay, so some way what I'll have to do is I'll have to take this value, and in some way I should have it controlling this channel. Alright, means later if I go and change the direction of this, if this is equal to sorry, if I go and change the length of this, of the line, this value should drive the translate of this, so that it moves simply along with the length of this. Okay, and it's very easy, guys. What you need to do, you just need to go to the line, copy the length of the line, copy this parameter, go to the transform and paste it within the translate, because you know that I need to move this, right? So the length, this should be the length of the line should be is equal to the length of the height of the circle, the transform of the circle, right? So I could just do what you know, either make this 1.66. I'm sorry, okay, 1.60, 87, 1.66. All right, it's exactly there. But then I want this to be interactive, guys. That means I want that when I change it like this will be interactive along with it. This should also go along with it. The tabletop should also go along. Okay. So that's why I'm copying this parameter. Okay, coming to the transform and changing this manually all the time wouldn't work. So in that case, what I will do is just right click and paste a relative reference. Okay. So when I hit enter, if I just click on this attribute name over here, I will see what is happening. It's 1.6i. But the, the thing is that it's showing me dark green in color. That means it's directly linked to the value here. So now if I change this value being connected directly to the transform of it changes. That is what is called a channel referencing. Okay? When I'm controlling one channel where with the help of which it directly controls the other channel, that is what is called a channel referencing. And just simply matter of right clicking and paste relative reference, not just paste value. Pasting value will just paste that value, but pasting relative reference will do so that it is going to refer to another channel for its value. Okay. One thing what I would like to make it clear here, that when I click here on this parameter name, I will get to see the actual value over here, which is definitely the length of the line. But when I click on it again, I will see what exactly is going behind the scene. So channel referencing, right? CH is the, so whatever you see code over here. Okay. CH is nothing but the channel. So it's referencing it from where it's going into, it's reaching out for the line, see, line 1, that is this, and its distance, right? So took a look here. Now it says length over here, right, guys? So you might ask me what is the distance if it is a length. Now really length is just a name, but if you hover over here, you will see that the parameter is the distance here down below. So that is what it's looking out for, and that's why what you see here is just doing a channel referencing for the line with on the distance parameter. Yeah, so hopefully that's clear. So now what controls do I have? Definitely I have the control of the length, the height of the table. I have control over the divisions. Okay. And yeah, I think we have those two controls. All right. Now some very basic things which we need to do is we need to add some poly extrude circle that I can adjust the distance. Right. Pull output box, close it. All right. So yeah, I will also do maybe one more extrude over here. I'm going to use one of the side groups over here. Side groups in the sense these are all the side groups. These are all the side groups. So I'm making them active. Okay, in fact, I will not make them active here. I'll make them active over here. Okay. Okay, and the next one which I'm using, I will just call that side group, and that extrude that distance, right? Like this. So it kind of falls outside, right? Okay. It's just extruding that group. So instead of using the group range, what I did, I used something which is within the node itself, where it allows me to actually create groups of the individual faces. I do have the output front, which is I think the top one, output back, which is the back, and output side. Okay. Alright, so having done that, let's actually think about the legs now. Mm, where is my leg? So this is my leg. So if this is my leg, I need to add something known as only wire, wire radius over here. Alright guys, so uh, what I'll do is stop it here for this section and later continue with the leg part. Okay, so yeah, thank you.